Hi, this is problem 2 for the behavioral analysis lecture series. These are sort of like what you consider as like homework problems that you could try. I recommend trying the problems first before you watch the rest of this video where I work the problem out. Now, this is a problem taken from J. Cummings' Real Analysis Long Form Mathematics textbook, and this is example 1.7 in the textbook. And so it says let max of x and y and min of x and y denote the maximum and minimum of x and y. For example, the min, and then it has the curly brackets meaning a set, but you'll see that the min of -1 and 4 is equal to the min of -1 and -1, which is equal to -1. And the curly brackets usually denotes a set, and with set, when you have a set, you don't list repeated elements. You only list them once. But you see that you have -1 and -1, so that's listed twice. And so it's possible to have x and y be the same thing. All right, so keep that. I just figured I'd point that out. So we're going to prove based on this definition of max and min. We're going to prove that the max of x and y is equal to x plus y plus the absolute value of y minus x divided by 2. And the min is equal to x plus y minus the absolute value of y minus x divided by 2. And then we're going to find a formula if it consists of 3 things, x, y, and z, for the max and min. And they give us a hint, use the fact for the hint that the max of x and y and z is equal to the max of x, comma, and then of y and z as its own little set. All right, so that's the problem. Again, I recommend trying it on your own. And so the first one, so I'm going to prove that the max of x and y is equal to x plus y plus the absolute value of y minus x divided by 2. Something to make note, so with absolute value, notice that we know the absolute value of some number a is equal to a if a is greater than or equal to 0, or it's equal to negative a if a is less than 0. Also, when you take absolute value of a minus b, that's equivalent to switching the order of doing the absolute value of b minus a. It gives you the same thing. I figured I'd go ahead and write those down because I will be using these two facts. All right, so we have two elements, x and y. And we could have x greater than y, x less than y, or less than y, not less than 0. I mean, it could be, but we could have x greater than y, x less than y, or x equal to y. And so I'm going to consider if you just do x greater than or equal to y as a case. And then because the greater than or equal to, you can treat it as pretty much the same thing. And then as far as how you handle it, and then doing x less than y for case 2. So just to test it out, this formula, let's say I wanted the max of 1 and 2. So we know that's 2. Now the formula says it's going to be x plus y minus the absolute value, or plus the absolute value of y minus x divided by 2. And in this case, x is 1, y is 2. So if we plug these into the formula, this is 1 plus 2 plus the absolute value of 2 minus 1 divided by 2. All right, so 1 plus 2 is 3, and then plus, and 2 minus 1 is 1. Absolute value of 1 is 1, so it'd be 3 plus 1 over 2, so that's 4 over 2, which is 2. So that checks out with this based on those two values. Now, if I switch it so it's like x is 2 and y is 1, it's the same thing, right? So that was just to demonstrate it. Now, obviously that's not a proof. All right, so do case 1, x being greater than or equal to y. All right, so proof. So assume x is greater than or equal to y. So what can we say about this? Well, if x is greater than or equal to y, then we know x minus y is greater than or equal to 0. And since that's positive or equal to 0, then we know the absolute value of x minus y is equal to x minus y. And we know the absolute value of y minus x is the same as the absolute value of x minus y. All right, so I figured I'd go ahead and note that. So now, so that's just some factual information. Now the proof. So we wish to show, so WTS, we wish to show that the max of x and y is equal to x plus y plus the absolute value of y minus x divided by 2. So I'll start with the left side. And so we know the max of x and y. Well, that's equal to x when x is greater than or equal to y. So if they're both the same, it's also x, but if x is greater than y, it's x. Okay, so then note so max of x and y is equal to x. And we can add 0 in the form of plus y minus y. So that's equal to x plus y minus y. Now notice in the equation, we have the x plus y. So I already have that. And there's this added thing of a minus x. So I can add 0 again, anticipating that hopefully I can get this form of, with the minus x or plus x, that I can rearrange this stuff so I can have the absolute value of y minus x somehow. So all I did was add 0 in the form of y plus y minus y. So now I'm going to add 0 again, this time in the form of x, because we need an extra x for that absolute value. So this will be plus x minus x. So that's again adding 0. So we have this, and this is equal to, and again, this is the max of x and y, which is equal to x, which is equal to all of this. And then that's, again, it's going to be equal to x plus y. And I can rearrange it by commutativity. And if I, for instance, I want y minus x, but the absolute value of y minus x, mind you, that's the same thing as the absolute value of x minus y. So this is the same as x minus y absolute value. I can have that because here I have x plus y, and then I can take one of these x's, so I can do x minus y, so it'd be plus x minus y, and then I have minus x. Well, the absolute value of x minus y is equal to x minus y, since we're assuming x is greater than or equal to y. So then I can replace the x minus y in green with the absolute value of x minus y. And then I have minus x. Well, another property with the absolute value, switch the order of the difference. That's equal to the absolute value of y minus x. And then I still have this minus x. So right now I have all of this. And again, the left side is really just max of x and y, which is x. So all of this is be equal to x, which we know is the max of x and y. So I can add x to both sides to get rid of that x. So then I have 2x equal to x plus y plus the absolute value of y minus x. And so I'm almost there because I'm trying to show that the max of x and y is, again, x plus y plus the absolute value of y minus x. I have all of that, and then I need it to divide by 2. So after adding x to both sides, I had 2x equal to x plus y plus the absolute value of y minus x. And x is the max. So really this is 2 times the max of x and y. So then dividing both sides by 2, that gives me my equation, x plus y plus the absolute value of y minus x divided by 2. All right, so that is what we wish to show. And that was the case in which x is greater than or equal to y. Now the other case is going to be x less than y, or y greater than x. So what do we know for this? If y is greater than x, then we know y minus x is greater than 0. And if y minus x is greater than 0, then we know the absolute value of y minus x, which is equal to y minus x by definition of absolute value. All right, and that's greater than 0. So that's information that's useful. Now I'm going to go into the proof, and it's going to be pretty much like what I did. So here, again, I'll start with the max of x and y. Well, the max of x and y is equal to y. All right, then I add 0. So y is equal to plus x minus x. Again, that's adding 0. And then I can add 0 again, plus y minus y. All right, so I have 0 added twice in the form of plus x minus x and plus y minus y. And again, I want to show it as eventually equaling x plus y plus the absolute value of y minus x divided by 2. Commutativity, I can switch this, so instead of y plus x, that's x plus y. And I know y minus x is greater than 0, so here I have a y and then the minus x. So this will be plus y minus x, and then I have the minus y. Y minus x is the same as absolute value of y minus x since y is greater than 0. So this is equal to x plus y plus the absolute value of y minus x minus y. And then I can add y to both sides. And again, all of this is y, which is the max of x and y. So then I add y to both sides. That'll give me 2y equal to x plus y plus the absolute value of y minus x. And then I divide both sides by 2. And note that y is the maximum. So this would be 2 times the maximum of x and y. So then max of x and y is going to be x plus y plus the absolute value of y minus x divided by 2. All right, so we've taken care of both cases. So for both cases, for either case where x is greater than or equal to y, or x is less than y, we have the max being equal to x plus y plus the absolute value of y minus x divided by 2. All right, so that's how you do that one. The minimum is done pretty similar, so I'll go ahead and do that. So for the minimum, it's pretty much the same thing. Instead of plus the absolute value of y minus x, we want to do minus. So we want to show the min of x and y is equal to x plus y minus the absolute value of y minus x divided by 2. And I'll have two cases, really 3, right? Because we could have x greater than y, x equal to y, or x less than y. So I'm going to break it up so that we have two cases where one of them is going to involve an equal to as far as the inequality sign because it's handled the same way. So we're going to have either x is less than y or x is greater than or equal to y. All right, so case 1, case I, let x be less than y. So if x is less than y, we know that x minus y is less than 0. And let's see, so then when we do the absolute value of x minus y, that's going to be equal to the negative times x minus y, because x minus y itself is less than 0. And we know that the absolute value of y minus x is the same thing as x minus y. All right, so these are just some facts that we know. And let's see. Oh, and notice in the formula, we have a minus times the absolute value of y minus x. Well, we can change this one. So that's if and only if the negative times the absolute value of y minus x is equal to x minus y. Just bringing the minus sign to the other side. And again, this is when x is less than y. All right, so I'm going to prove that the min of x and y is going to be equal to x plus y minus the absolute value of y minus x divided by 2. So this case, again, x is less than y. So if x is less than y, then the min of x and y is going to be equal to x. And then I can do what I did before and add 0. So if I add 0 in the form of y, so that would be plus y minus y. So that's adding 0. And then I can add 0 again in the form of x. And now it's just a matter of rearranging this into the correct order and then using absolute value definitions. So I have the x plus y. And I have minus y plus x and minus x. So notice here, x minus y is the same as minus times the absolute value of y minus x. So I'm going to keep this x and then this minus y. So we plus x minus y. And then I have minus x. And in green, that x minus y is the same as negative times the absolute value of y minus x. Again, because since x is less than y, then we have the absolute value of x minus y is equal to negative times x minus y. And we know that x minus y is the absolute value is the same as the absolute value of y minus x. And so we could bring the minus sign over so that we have minus times the absolute value of x, y minus x is equal to x minus y. All right, that's what I said earlier. All right, so now I'm going to erase this so it's less cluttered. Okay, so that pretty much, I mean, we know what we're going to do from here. I'm assuming because we have this is x, I'm going to add x to both sides. So then you get 2x. X is the min, so this is 2 times the min. And then divide both sides by 2. All right, and that's what we wanted to show. All right, now that's the case when x was less than y. Now I'm going to do the other case. So case 2 is x is greater than or equal to y, or y less than or equal to x. And it's pretty much similar stuff we're going to do. So if we know this, then we know that y minus x is less than or equal to 0. And so we know the absolute value of y minus x is equal to the negative times the absolute value, or negative times y minus x, since y minus x is less than or equal to 0. And so negative times the absolute value of y minus x is equal to y minus x. Right? I think that should be true, right? Because x minus y is greater than or equal to 0, which is y minus x is less than or equal to 0. And yeah, so now I'm doing the min of x and y in the case in which x is greater than or equal to y, or y less than or equal to x. So we know the min is going to equal y. And like before, I'm going to add 0. So if I add 0 in the form of x, it'll be y plus x minus x, adding 0, and then I add 0 again in the form of y. So I can switch the order of y plus x into x plus y. And let's see, what do I need? So y minus x, so I do have the y, and here's my minus x. And then I have minus y. Well, y minus x is the negative absolute value of y minus x. Right, because of what I stated earlier, based on these sort of facts. So all of this, again, so we know the left side's y. So we add y to both sides, so you have 2y. And that's the min. And you divide by 2. So dividing by 2 and noting that y is the min, then you have the min of x and y equaling x plus y minus the absolute value of y minus x over 2. All right, and that takes care of that. Okay, and the last bit's just finding a formula. And so we're going to find, so finding a formula for the max of 3 things, x, y, and z, or the min. And the hint is pretty much what we need. They tell us that the max of x, y, and z is the same as the max of x with the max of y and z. Well, essentially from the hint, we can just plug it into our already known formula. So we know if we have the max of 2 elements, and I'll do x and then y in the other in another color, we know that's x plus y plus the absolute value of y minus x. All of that divided by 2. Now, the reason I did that in another color is because where you see the spot for y, we can put the max of y and z in that spot. And that'll give us our formula. And so we get the max of x, y, and z will be equal to x plus the max of y and z. Plus the absolute value of the max of y and z minus x. and then divided by 2. Because we narrow it down to like 2 elements. Whenever we have like max of x, y, and z, it's the same as the max of x, with the other element being the max of y and z itself. And then that element of max y and z is what I put in the spot for the second element y. And that's the formula. And so the min is pretty much the same thing. It's just going to be min x, y, z equal to x plus the min of y and z minus the absolute value of the min of y and z minus x. And all of that divided by 2. All right, so that's problem number 2. This formula stuff, I'm pretty sure I'm correct with that. If you want to double check, you can. And you can put in the comments if this is incorrect for the formula part. But I know for proving the formulas, this is all correct. And I'm 99% sure the formula stuff is correct. I always have self-doubt. So that's pretty much it for this one. And you probably didn't have to do it as detailed as me. You probably could do like with loss of generality kind of thing. Assume x is greater than or equal to x, for instance, and then you don't need to do the other case since it's pretty much the same thing. It's just we're switching the role of x and y, and similar for the min. All right, so that completes this video, and next video I'll do a different problem.